So, the first question that arises is, what is steganography? Simply put, steganography is the art of hiding data in an image. Traditionally, steganography has been confined to covert and military communications along with DIY enthusiasts of steganography and cryptography. However, these days, with privacy being all the rage in society, steganography is finding its use in public communication. Of course, our project isn't a military-grade encryption system, it's just a dive into this ocean of data encryption. Simply put, the input is converted into letters. The letters are converted into their ASCII counterparts, and finally the ASCII values are converted into their binary values. These binary values are then stored into the image. Let's find out how. Images are made up of pixels. Pixels consist of three components: the red component, the green component, and the blue component. The RGB values, we're using these RGB values to store data in the image. So basically, we are taking 0 for even and odd for 1. So if you want to store 1 in the pixel, we convert the R, G or B, whichever value, into odd. And if you want to store 0, we convert it into even. This is arbitrary, we can do the opposite. Okay, now that that's done, how do we store data into the image? So suppose you want to store H into the image. So H is one character, it means 1 byte. 1 byte is equal to 8 bits, so we need 8 values to store 1 byte of data. So what we do is we take 3 pixels. 3 pixels is equal to 9 values, which is like 1 more than 1 byte of data. So we use the 9th value for a very important function. Suppose you are the compiler and you're decoding the data from the image. How do you know that, okay, I'm done with decoding process and I can give the output? For this, we're using the 9th pixel. Suppose the value of the 9th pixel is even. We say, okay, you're done with the program. And suppose we say it's odd, we'll tell the compiler to continue with the program. Again, this is arbitrary and we can do the opposite. Okay, so we are done with storing data into the image. However, there's a small problem. Anyone with this program should be able to access the information stored into the image. So what we have done is we have used the simplest possible cipher, which is the Caesar cipher, and we have used it to encrypt and decrypt the information which is coming in and out of the image. That's all good, but the problem with the Caesar cipher is that it's the easiest cipher to break. It's really simple to break the Caesar cipher, as you can see. However, this can be easily overcome by using multiple layers of cipher, like combining this cipher with a Wigner cipher. However, in this project, we have constrained ourselves to just using the Caesar cipher, and adding a Wigner cipher layer is something we plan to do in the future.